Hey everybody, Mr. Smith here. This is going to be a pretty fast video for you today. I only have two examples to look at. In the last video, we talked about factoring polynomials in standard form. In this video, I'm going to give you two kind of special cases or strange examples of what might happen when you try to factor these types of polynomials. So, first example, number one here, if I ask you to factor this polynomial, this is an example of when there's a GCF. So, one rule that you need to try to burn into your brain right now is when you're factoring a polynomial, you always want to look for a GCF. And remember what a GCF is. That's something that I can divide each one of these terms by. And if there is a GCF, then you want to factor that out of the polynomial before you go ahead and factor it. So if I'm looking at this polynomial, I see there's a 5, there's a 15, there's a 10. All of those things are divisible by 5. That's the biggest number I can divide them all by. So I know that I could factor a 5 out of that. Only these two terms have an x, so I know I can't take out an x. The only thing I can factor out is a 5. So that leaves me with x squared. Remember, I'm just dividing each of these by 5 now. X squared plus 3x plus 2. So I've factored this 5 out of everything, and now I'm left with this polynomial. Now what I'm going to do is essentially just ignore the 5. It's just going to come and stand in front here, and it's not going to do anything. And I'm going to factor what I have inside these parentheses. I'm going to factor that polynomial using the method that we learned in the last video. So remember, I'm going to multiply the first and the last two numbers. It's the a times c add to b process. Multiply the first and the last two numbers. There's an imaginary 1 right here. So that's 1 times 2 is 2. And now I just need two numbers that multiply to 2 and add to 3. Well, clearly that's just 2 and 1. 2 times 1 is 2. 2 plus 1 is 3. So that checks out. Remember, in the process now, I would take this polynomial, break it up into pieces using this. I'm still going to do that, but I've got this 5 sitting in front. So that's going to come with me. I'm just going to bring it down here. It's not going to do anything. I just don't want to forget that it's hanging out in front. So I'm going to write it. And then I'm going to write this polynomial, x squared plus 2x plus 1x plus 2. Okay, the 5 is still in front, but I'm kind of ignoring it. I'm just bringing it down so I remember I have it. Okay, now I've got this polynomial with 4 terms. Now remember what we did here is that we broke it up into 2 halves and we did factor by grouping. So I'm going to look at the first piece and see if there's a GCF I can take out. Well, I can factor an x out of that. So that's going to turn this into x plus 2. And then I'm going to look at this second term and see what I can take out of that. And remember, whatever I take out of this polynomial, or whatever I take out of this half, I want it to end up matching this x plus 2. And maybe you already noticed this. It already is x plus 2. This already matches this. So I don't really need to factor anything out of this in order for it to match. We're going to come across this type of situation a lot. And if you do, you can kind of be tricky and say, well, I know it's already matching. So I'm just going to say I'm going to factor out a 1. It's like you're dividing each of these things by 1, and it doesn't change anything, but you're still factoring something out. So I factor out a 1, and I have x plus 2 in there. And now I've got my 2 repeated factors, and I've got my 2 GCFs that I pulled out. So just like from the video video, my final answer is going to be that repeated factor, x plus 2 times x plus 1. The 2 GCFs put together. But remember, I still have that 5 sitting in front. I need to make sure I include that. So I write the 5 in front of everything, and now this is going to be my final answer. So when you have a GCF, factor it out first, and then factor what's left, just like you normally would, all the while knowing the GCF you pulled out is staying with you throughout the entire process, and then write it in front of everything when you're all finished up. Okay, let's look at one more special case. It's example 2 right here. X squared minus 25. This is an example when the b term, remember we can think of our standard form like this. Oops, this is bx. When b equals 0, so when the middle term equals 0. Okay, notice how, let me give you a little bit of clarity here. X squared minus 25. If I wrote this as x squared plus 0x, minus 25, that's the same thing as x squared minus 25, because this 0x, I could just erase that and I would have what I originally started with. This is just to show you that the b term technically in this polynomial is 0. Okay, so now I can just factor this the exact same way I would have factored this polynomial over here. I'm going to multiply the first and the last term. 1 times negative 25 gets me negative 25. And I need two numbers that multiply to negative 25 and add to 0. Well, the only factors of negative 25 are the only factors of 25 are 5 and 5 and 25 and 1. 25 and 1 clearly doesn't work. I know that one of these needs to be negative in order to get it to be negative 25. So let's just say negative 5 and 5. And this is kind of a shortcut. When you have a problem like this, once you find your two numbers, turns out that's all you need. Okay, you can immediately just say that your answer is going to be x minus 5 right there times x plus 5 right there. At this point, I can say that I'm done. I'm going to show you why that is. I'm going to show you how you could actually prove that this is the answer. I'm just telling you, in this type of problem, once you find your two numbers, you're done. But I will show you how I get there. So I've got my negative 25. I said I'm going to use negative 5 and 5 as my two numbers. And I'm just going to continue the process that I've done in all the other standard form factoring problems. I'm going to rewrite my first polynomial, x squared minus 5x plus 5x minus 25. And now we're going to do factoring by grouping. In this first half, I can take out an x minus 5. In this second half, I can take out a 5, it looks like, and that's going to match to be x minus 5. So if I factor out 5, I get x minus 5. Okay, so now I've got my two repeated factors, I got my two GCFs, and if I put them together, it's going to get me x minus 5 times x plus 5, which is exactly what we got up here. So for a shortcut method, when you have a problem like this, once you find your two numbers here, you can immediately jump to your final answer. I'm just showing you here how we end up getting there. Okay. So just those two examples for you today of some special cases that may come up when you're factoring polynomials in standard form. If you have questions, please let me know. I'm here to support you guys. All right, we'll talk to you soon.